Welcome back, nerds. Pre-calculus, transformations. Let's do it. We're going to finish it. What did I say? Pre-calculus. No. Wishful teaching. Ha! All right. Well, whoever you are. Nerds. Okay? All right. Anyway. Transformations. Let's get it finished up. I am not good with spatial mathematics. And this is a true statement. We used to have these things when I was younger. They're called maps. And they're made out of paper, and you'd unfold them, and you would try to follow them to go places. For me, though, I can't follow a map unless I turn the map so that up on the paper is whichever direction I'm looking. I just can't. I can't follow it when left isn't left and right isn't right. Also, like drones and RC cars and stuff like that, I can't control those things to save my life unless they're going directly away from me, because I don't rotate things very well. And it's the truth. I'm just bad at it. So to ask me to take this weird image of a quarter circle and a straight line and perform 3 different transformations on it in my head is an impossibility. I just can't do it. In geometry, I might have been able to get away with shifting it maybe twice, maybe reflecting it. I don't know. 1 transformation I could probably pull off, but not 3. So I can't just draw the new image. I can't do it. So what I have to do, and what I had to do, was track the coordinates. And that's why I told you transformations don't change graphs, they change coordinates. So what I would do is I would pick out, at least on this image, 3 points that are really obvious. So that one, and that one. Now, I could also track this point right here, 2, 1, but it's not really necessary because there's no reflections. And I know there's no reflections because I don't have a negative sign in front of my f, and I don't have a negative sign in front of my x. If there were transformations, I might suggest tracking the 4th point as well. Just that way you know exactly which part was supposed to be curvy and which part was supposed to be straight. So on your homework, I would track at least 4 points. 1, 2, 3, 4. Okay. And once we know what those coordinates are, we determine what the 3 transformations are and how they affect our coordinates. Remembering that inside transformations are x changes, opposite of what they look like. Outside transformations are y changes. They do exactly what they look like. So let's describe our 3 transformations. There's only 1 transformation on the x's, right there. So we have 1 horizontal transformation. Horizontal, inside, opposite. Who could tell me what that's going to do to the graph? Daniel Q. Going to make it shift left 1. That's the description. But what does it do to the coordinates? Well, if you're on the x-axis and you move to the left, did you add or subtract to your number? Subtract. So this is going to literally subtract 1 from our x values. Now the verticals. There's 2 of them. There's a times 2 and there's a minus 3. Which one do you think we do first? Parker, why would you think times 2 first? Yeah, that's the right answer. So yeah, we're going to handle the multiplication before the addition and subtraction because PEMDAS. And outside changes do exactly what we think they should. They're going to follow PEMDAS. So this one on the front is a multiplication, and all multiplications are either stretches or shrinks. And since outside changes do exactly what we think they should be doing, this is literally multiplying your y values by 2. So that's making something bigger. Vertical stretch, factor 2. Mathematically, though, I've already said it, but what does that do? That literally multiplies your y values by 2. And then, after we've doubled the y values, we do that to that. Vertical, outside, same, meaning it does exactly what it looks like it's doing. And addition and subtraction, we said, is always a shift. So this is literally shift down 3 units. And on the y-axis, when you go down, your numbers get smaller. So you will subtract 3 from the y's. All right. The 3 coordinates, I'm going to write them down as x comma y in a point tree. First one to the left is -2 comma 0. Remember, we always read our graphs from left to right. I have a 0, 2, and I have a 4, 0. For the x's, we said we're going to subtract 1 from them. So -3, -1, +3. There, I subtracted 1 from all 3 of my x's. But the y values. First, you multiply your y's by 2. Then you subtract 3. Zero times 2 is 0. -3, -3. 2 times 2, 4. 4 minus 3, 1. And we already know what happens when we throw a 0 in. We get a -3. Connect your dots. Well, I guess plot your dots and then connect the dots. So I have a -3, -3. I have a -1, +1. And a 3, -3. If you didn't know that there was already a curve here, then you might try to connect those with a straight line. And that's why I was saying at least those 3 points. But if you couldn't remember which one is which, then like which was supposed to be the straight, which one was supposed to be the curve, then track this point in the middle. And just for funsies, that point in the middle is a 2, 1. So move it to the left 1. The y value is +1. Multiply it by 2, I get 2. Subtract 3, I get -1. So it goes right here. So this shows you where the straight line is. This is the curve. This is the straight line. And I absolutely could not have done that in my head. I just can't. I'm not good at it. So I treat all my transformations as arithmetic on x values and y values. What do you think? I'm hoping that your thinking transformations really aren't that scary when they're done this way. You guys don't talk to me much, though. Okay, wow. Rousing. Here we're going to take the equation f of x equals x squared. And for part A, we're going to do these 3 transformations in the order that they're listed. First, horizontal shift, 2 units to the right. So shift right 2 units. Horizontal, inside, opposite. And anytime you do anything on the inside, it's a replacement. 2 units to shifting, 2 to the right. Remember, all shifting is plus or minus. And inside opposite, so instead of saying +2, I'll say x minus 2. A vertical stretch, factor 3. That means multiply by 3 on the outside. And then translation 5 up. Shift up 5 units. Vertical, outside, same. Plus 5 on the outside. So for part A, we're going to replace our x with an x minus 2 in some parentheses. We're going to put a 3 on the front and a plus 5 at the end. Good morning. Good morning. Good Lord. Now that the lockdown is over, I'll just have to, I don't know if I have the ability to stitch these together or if I just have to post them separate. I don't know. Anyway, here we go. Anyway, so what are we doing? Oh yeah. So part A. It's so disruptive, so disruptive. I didn't even know that was happening today. Part A. All we have to do is take our f of x, and where had x, throw this set of parentheses, put a 3 in front, and a 5 at the end. And obviously I would change its name. I mean, I wouldn't leave it like that. So let's call this one g of x. You see, following an order, or following a list of transformations, it's not that difficult as long as you know how to turn each of the words into function notation rules, and then you know how to apply those rules. Now part B says, hey, do the same 3 transformations, just do them in the reverse order, and let's see what happens. What color do I want to write in? I'll use black and blue. Blue feels good. Okay. So rather than starting with that shifting 2 units to the right, I'm going to make that one the last one. So I have to do this one first, and I am going to list them like this, you know, top down. So A, shift up, not the other SH word that he just said over there, shift. We're not shifting our pants anywhere, okay? Anyway, it says shift up 5 units. That's going to look like this. So the first thing that we would do is we would write plus 5 at the end of our function. And you know what? I want to go ahead and I want to do that step down here. There. The next thing I would need to do is this one, a vertical stretch by a factor of 3. Let's just say for the moment, I had renamed this because it is a new function. I could go ahead and rename it right now if I wanted to, right? Let's just say I called it g of x. It's not this g of x. You see, I don't want you to have to go through a million letters, but I want this to make a lot of sense. Well, screw it. Let's just go ahead and change his name. If at this point you wanted to do a vertical stretch of factor 3, you know that means multiply by 3 on the front, right? But I've been teaching you this whole time that if you're going to do that, you need to use parentheses, right? And I said wrap the whole left side in parentheses. That way you realize you need to wrap the whole right side in parentheses. Because once you've done that, look what you have. Distribute this 3, and you'll get a 3x squared plus 15. And then lastly, replace your x with an x minus 2. What I wanted you to see, though, is when you write it out, it will look like this. I used green, so I'll go ahead and use green. And then the last thing we need to do, like I said, is replace our x with an x minus 2. So we end up with this wild function notation rule where we've replaced the name, we've replaced the x. I mean, I got all kinds of wild stuff going on, right? It would end up looking like this. Where I had an x, put a set of parentheses, and do it like that. I don't know, I'll call it j of x or something like that. First of all, is the purple equation the same as the red equation? Are they identical? No, they are not. So clearly, the order of the transformations makes a difference. But I'm hoping you'll notice that there's one part that I could have done at any point in time for either the green or the purple. And that part was this one. This was my only x transformation. It could have come first, second, or third and would not have changed the results. Either way, I ended up with a set of parentheses at the end that said x minus 2 squared. But notice that switching the order of the vertical transformations changed the equation. What that tells us is, if there's more than one transformation in the same direction, order is going to make a huge difference. Believe it or not, there is an order of transformations. Other than order of operations, there's an order of transformations. And a lot of times, you're asked to describe the transformations that you saw occur. So on the red one, without reading anything up above, I would have said, and exactly like we talked about a minute ago, vertical stretch factor 3. You could say this whenever you want. Shift right 2 units. Shift up 5 units. I just made sure that I followed the order of operations here. But if you follow the order of operations on the purple one, it doesn't say shift up 5. If you just follow the order of operations when describing what you see, you say vertical stretch factor 3. Shift right 2 units, shift up 15, which is a perfect description. And so was this in reverse order. What I'm getting at is there's more than one way to get to the same equation, but if you're going to describe it, describe what you see and take the easy road. I would never say, let me go up 5 first and then vertical stretch factor 3. That's just a pain in the butt. That's like 4D chess. I want to do exactly what I see, and I want my life to be easy. I see a times 3 and I see a plus 15. Just make your life easy. So in this box, what we're going to do is we're going to write down the order of transformations. And when I say order of transformations, I mean describing what we see in equations. And Parker hit the nail on the head earlier with the vertical changes. He said, follow PEMDAS. He's absolutely correct. Do you know why we follow PEMDAS? For transformations? At least for the verticals? Because vertical outside same. That's why. They do exactly what we think they should. I don't know why I wrote equals. They follow PEMDAS. So if you see multiple y transformations, just follow the order of operations. Your multiplications will always come before your additions and subtractions. Please remember, a negative sign is a reflection. It's its own thing. Okay. So would anybody like to take a stab, predict the order of horizontal transformations? Other than Parker? Appreciate you though. Really? He's the only brave one? Someone in third period guessed and was right. Jake? Was that a volunteer? What? I don't know. You just stretched with one arm. It looked like you were volunteering. This guy doesn't even know the question. I said, vertical transformations, when we have to describe them, when we describe what we see, we use PEMDAS. But what if there's more than one horizontal change? Any guess at an order that we need to follow? Guys, would take a guess. Okay, thank you, Barry.
Is it like the opposite order?
Yeah, because horizontal inside opposite. It follows SADMEP. PIMDAS in reverse order. Because inside changes are opposite. SADMEP. Of course you haven't. It's just PIMDAS in reverse order. I just made it up. But PIMDAS is made up. But look, you're comfortable with following PIMDAS. Well, we follow PIMDAS for vertical transformations. They do exactly what we think they should. Whereas all the stuff on the inside does the opposite of what we think it should. So it follows PIMDAS backwards. And would you know, I think I'd been teaching transformations for 3 years to Algebra 2 regular students, struggling with trying to figure out a way to tell the students you always follow these orders. Because a lot of teachers will tell the students just follow the transformations from left to right. And I say, yeah, you can get away with following them from left to right as long as there's not more than one horizontal transformation. But if there's more than one horizontal transformation, you can't say go left to right. And I struggled for years to try to figure out one rule that I could always tell my students. You could always follow this and it'll always work. And my best friend down in Northport that taught it, neither one of us could come up with anything. And then one day, when telling the students, the vertical transformations are going to follow the order of operations, are going to follow PIMDAS, a student said, does that mean that the X values follow PIMDAS in reverse? And it was like this light bulb smacked me in the face. And I was like, yeah, yes, that's actually exactly what you do. It was a student who said it to me. And for some reason, it had never occurred to me. I stopped teaching right then and there. I called my buddy down at Northport. And he was like, hey, horizontal transformations, you ready for the order? And he goes, sure. And I go, PIMDAS in reverse. And he's like, yeah, that makes a lot of sense. Yeah. Both of us, math degrees. Both of us knowing how to get right answers. Neither one of us being able to explain to the students, here's something that always works. That always works. Always. A student said it to me. I love teaching. No. It's just that people's brains are all different. And every now and then a student will say something in a way that I've never thought of before. And I go, wow, yeah. No, yeah, that's exactly true. I just never thought of that. And SADMEP for multiple horizontal transformations. PIMDAS for multiple vertical transformations. So here we go. What we're going to do is we're going to describe these 4 transformations in a correct order. I think it's really important to drive home the idea, though, that X changes don't change the Y's, and Y changes don't change the X. What that means is it doesn't matter if I do the 2 vertical first or the 2 horizontal first, or if I decide to switch them or say them backwards or shuffled. It doesn't matter. All that matters is that the vertical changes get described in the correct order and the horizontal changes get described in the correct order. That's all that matters. For the vertical changes, we're going to follow the order of operations. The first thing we see is this multiply by -1 on the outside. Anybody remember what multiplying your Y values by -1 does? Reflect. If it's going up and down, what axis did you go over? Here you go, reflect over X axis. That's what the transformation does. This. But if you were just working with a coordinate, that just multiply your Y values by -1. That's all that does. Multiplies Y values by -1. But that is the first vertical transformation. The second vertical transformation is back here. Vertical outside, same. Does exactly what it looks like it's doing. Shift up 4 units. What does that do to the numbers? It just adds 4 to them. So this has told me multiply my Y values by -1 and add 4. That's how I would manipulate the coordinates. Multiply by -1, add 4. Now the horizontal transformations. Because they follow the order of operations in reverse, am I going to handle the 3 first or the 1? You guys can just shout it out. What gets handled first, the 3 or the 1? The 1 does. PEMDAS in reverse order. If you're not writing in color, label these numbers 3 and 4. But I am writing in color. And I think it's really important that you understand that these two didn't have to come first. They just had to happen in that order. The first horizontal transformation is the +1. Horizontal inside, opposite. Shift left 1 unit. Going left on the x-axis, make the numbers bigger or smaller? Makes it smaller. So it's literally subtracting 1 from the x values. And then lastly, the ×3. Horizontal, inside, opposite. It looks like I'm multiplying by 3. What am I actually multiplying by? Can someone tell me what's that? Dividing by 3, but let's say we're multiplying by, not negative, negatives reflect. 1/3. So it's not wrong to say divide by 3, but it's more correct to say multiply by 1/3. But if you multiply a number by 1/3, does it make it bigger or smaller? Makes it smaller. So would you describe that as a stretch or a shrink? Shrink. So we have a horizontal shrink, factor 1/3. Now mathematically, what is it doing? Just what Brock said. It's dividing by 3. So if you had an x value for some coordinate, first you would subtract 1 from x, then divide by 3. That is how you would manipulate a coordinate. You would do this to the y's and this to the x's. Done. Okay? So I want to practice that in our little bit of time that we have left because the lockdown drill took time away from me. I wasn't expecting. 1, 2, 3, 4 transformations have occurred here. I want you to try to predict, well, use the transformations to figure out where this coordinate would go. Well, you guys want to do x's or y's first? I don't care. Y's first? Okay, so verticals. Let's do the verticals. For the verticals, I have a 4 and a 5. Order of operations says multiply first. I had to do this one first. Then I'll do this one. Here is the coordinate we had. Oops. On this -2, the first thing we have to do is what mathematically? You can say it louder. Multiply by 4. And then after we've multiplied by 4, what are we going to do? Add 5. Good thing Trent was here. -2 times 4 is -8. -8 plus 5 is -3. Let's do the x now. Order of operations in reverse because inside changes are opposite. What is this going to do to my x value? It's the opposite of what it looks like. Yeah, Jake? No, just this part that's, oh, no, you're not wrong, but I mean, that's the answer. But what I want to know is, what are we doing to get there? How did you get that number? Oh, okay, so we're going to subtract 2. Oh, you sure? It's opposite, remember?
Oh, so add 2.
There we go. That's a shift right 2. And then after we've added 2, what is this going to do to my x value? Do you want to try again, Jake? Yeah. What's it going to do? It's going to multiply by 2. My man. So the first thing you do to that x is add 2, make it a 3, and then you multiply by 2 and make it a 6. The coordinate 6, -3 is where that point would land after all of that junk. Nerds, I thank you. I think you got this.